This is the homework video notes for solving systems of inequalities. So we've solved systems of equations before, and our answer is where they intersect. We've also graphed inequalities where we have a line with a shaded region. So what a system of inequalities is two inequalities with two different shaded regions, but the solution is where both of those shaded regions overlap. So we're going to follow the steps above. Graph the first line. Y is less than 2x plus 4. So I know I'm going to be using a dotted line. And then I have my y-intercept and my slope. So my y-intercept is 4 and my slope is 2. So I'm going to plot a couple points. Because I need a dotted line, I will connect these with a dotted line. Now the second part of step 1 says we need to shade the correct side. So this is where we pick a point to test it. I always pick 0, 0 unless that is on the line. So I get 0 is less than 2 times 0 plus 4. That means I get 0 is less than 4. And that is true. So I'm going to shade, again, I'll keep to the same color, the side that I tested my point on. Now let's go ahead and do step 2 where we graph our second line. I'll use orange for this one. We have a y-intercept of positive 1 and a slope of 1. So I plotted a few points, and then for this one I need a solid line because it is a greater than or equal to. So let's find my line and solid. Now I need to pick a point and test it. Again, I'm going to use that red point at 0, 0 because it is not on the line. Plug it in. 0 is greater than or equal to 0 plus 1. Is 0 greater than or equal to 1? No. So that is not a solution, and I need to shade the other side. So again, I'm going to use orange because the line is orange. So I'm shading this side of the line. So my solution is where those two shadings intersect each other. So where I have blue and orange. So my shaded region where I have them both intersect each other is right here. Let's try another example. Both of these are in standard form. So in order to save time, you guys know how to do your intercept tables, so you can pause it if you need to take the time to do that. But remember, standard form, you use the intercept tables. So my first graph, I'm going to use purple this time. I have intercepts of -1 and -1. And then I have to look and see what kind of line do I need. It's less than or equal to, so I need a solid line. Let's pick a point and test it. So 0, 0 looks good again. I get 0 plus 0 is less than or equal to -1. That is false. 0 is bigger than -1, so I'm going to shade the other side. So I'm going to shade underneath. Let's graph that second line. So I will graph this using green. Again, use the intercept table to the right. I'm going to save time and just do it. I get intercepts of 3. 0, 3, and 3, 0. And again, I need a solid line because it's greater than or equal to. So already I can see I have parallel lines, which is pretty cool. And I'm going to test 0, 0 again. Is 0 plus 0 greater than or equal to 3? No. So 0 is not a solution, and I need to shade the other side. So that will be over here. But we run into an issue because the shaded regions do not intersect. This means we have no solution. Go ahead and do the 2 U-tries, and then resume the notes on the next slide. Alright, so this is extra. If you do not want to watch this, you don't have to, but this is something called reverse shading, which kind of makes things a little bit neater, so we were going to show you. We do the same exact steps, only instead of shading the side where you get a true statement, you're going to shade the side where we get false statements. So let's go ahead and graph these lines. For my first line, I get an equation in standard form, so I'm going to use my intercept tables. When I plug in 0 for x, I get y is -2. When I plug in 0 for y, I get x is equal to 4. So I'm going to use green for my first graph and plot those points. 0, -2, and 4, 0. I'm going to be using a dotted line because of the inequality sign. So here's where things change a little bit. I'm still going to pick a point, and 0, 0 works great again. I want to plug it in. 0 minus 2 times 0, which is 0, is greater than 4. Is that true? No, 0 is less than 4. It is false. But because we're doing reverse shading, we're going to shade where it is false. So I'm actually going to shade where that point is, because this is reverse shading. Let's look at our second line. So we have x is greater than or equal to 1. Remember, that is a vertical line, and I'm going to be using a solid line. So at x is equal to 1, I have, oops, that's not solid, a vertical line. And I'll pick 0, 0 again and plug this in. 0 is the only one I can plug in. Is 0 greater than or equal to 1? That is false. So again, because it's reverse shading, I'm shading the side it is false on. So it's false on the left side. So my solution is where there is no shading at all. So if you want to try reverse shading, you can, as long as you label where your solution area is. That's what we are looking for. So you just have to tell us if you're using regular or reverse shading. Go ahead and do the U-try, and that's it for your homework tonight.